Alright, in this video we're going to utilize a technique for integration by parts known as solving for the unknown integral. And this is used when we have exponential functions paired with trigonometric functions, the two lowest on our LIPET hierarchy. Because what happens is when we take the derivatives and integrals of exponential and trigonometrics, they're never going to decay away or disappear like logarithmics or inverse trigs or polynomials will. And so no matter what we do, we will never get an integral that we can find simply by using anti-differentiation. So we utilize this technique. Here's what you need to do. You're going to need to keep the original integral on the left-hand side of the equation. And then you're going to integrate by parts on the right-hand side. You'll end up needing a second application of integration by parts on the right-hand side. And after we apply it for the second time, my integral of v du that's on the right-hand side should match the original integral, or be some multiple. And then we're just going to do some algebra in order to find the final integral. So let's take a look at what that looks like. We're going to find the integral of e to the x sine of x dx. So using LIPET, I'm going to let u be equal to e to the x and dv be equal to sine of x dx. And then du is e to the x dx. And v is negative cosine of x. And so when I set this up, I'm going to leave the original integral on the left-hand side of an equation. And that's equal to u times v minus the integral of v du minus negative cosine, so that's going to turn into a plus sign. And this is a very similar integral on the right-hand side now. We have an exponential and a trigonometric. And we're going to apply parts again. So we've got u equals e to the x, and dv equals cosine of x dx. So du is equal to e to the x dx, and v is equal to sine of x. And so now, taking my equation again, got integral of e to the x sine of x dx equals negative e to the x cosine of x plus u times v, which is e to the x sine of x, minus the integral of v du. And what you should notice now is that these two integrals are the same. And so, in order to find the value of the integral of e to the x sine of x dx, I'm going to add integral of e to the x sine of dx to both sides. Now, when I do this, I want to make sure that I introduce my constant of integration on the right-hand side, since I no longer have any integrals there. Now, the last thing I need to do to find the value of my original integral is divide both sides by 2. And so I'll divide this side by 2, and then I divide the right side by 2, and there's the value of the integral that I'm looking for, the integral of e to the x sine of x. Alright, let's do one more example here. The integral of e to the 3x cosine of x. So to start, u is going to be equal to e to the 3x and dv is going to be equal to cosine of x dx. So du is 3e to the 3x dx, and v is equal to sine of x. And so now the integral of e to the 3x cosine of x dx is equal to u times v minus the integral of v du. I'm going to bring the 3 out in front here. And then I'm going to apply integration by parts again. U equals e to the 3x, dv equals sine of x dx, and now in this case, du is going to be 3e to the 3x, and v is going to be negative cosine of x. And now I've got, let's see, integral of e to the 3x cosine of x dx equals e to the 3x sine of x minus the quantity u times v, so that's negative e to the 3x cosine of x minus the integral of v du, and since I've got a negative in there, I'm going to change that to a plus. Oops, forgot my 3 out in front of those parentheses. That's going to be very important. And then this is going to be 3 e to the 3x cosine of x dx. Alright. Now, I have my matching integrals that I want. But before I start doing the algebra here, I'm going to actually distribute this stuff out. So I've got integral of e to the 3x cosine of x dx equals e to the 3x sine of x plus 3 e to the 3x cosine of x minus 9 integral of e to the 3x cosine of x dx. Now I'm going to add those 9 e to the 3x integral of e to the 3x cosine of x dx to both sides. Give me 10 integral of e to the 3x cosine of x dx equals e to the 3x sine of x plus 3 e to the 3x cosine of x. And now I introduce my constant of integration. Now I'm going to divide both sides by 10. And that's going to give me the value of the integral that I'm looking for. So we've got 1/10 e to the 3x sine of x plus 3/10 e to the 3x cosine of x plus c. And there's my integral. And that's the end of that video on solving for the unknown integral.